Today I'm going to explain you some problems that I've already sent to you using some of the properties of vector identities. So here as you have, let me discuss with you this problem, how they got in using that one of those vector identities. Proof that divergence of r to the power n into r bar. R to the power n, it is a scalar quantity. R bar is a vector which is in the form of xi plus yj plus zk cap is equal to n plus 3 into r to the power n. So directly you can solve this using the definition of del dot of r to the power n into r bar. But if you are using one of those vector identities, so the one of those vector identities where you can solve this problem, you can use that vector identity 3, that is divergence of phi a bar is equal to gradient of phi dot a bar plus phi into divergence of a, or you can write phi into divergence of a bar plus a bar dot gradient of phi, where phi here is a scalar quantity and a bar is a vector. Now if you compare this question with this vector identity, you can take phi to be r to the power n, which is a scalar, and a bar is equal to r bar, where r bar is equal to xi plus yj plus zk cap. And we know that if you take divergence of r bar here, it is nothing but del dot r bar according to definition of divergence. And what is this operator del? It is I del x plus j del y plus k del z dot of r bar. But what is vector r bar? Is xi. Using this divergent rule, here we have I dot into del r bar del x plus j bar dot into del r bar del y plus k bar dot del r bar del z. Now let us apply what is r bar here. R bar is xi plus yj plus zk. So you replace this r bar by this. So we have I dot into del x of xi plus yj plus zk cap, plus similarly j bar dot of del y of this plus k cap dot of del z of xi plus yj plus zk cap. Now if you differentiate this partially, what we have is del x of this. Differentiating partially means you are differentiating it with respect to x by keeping y and z as constants. So what is del x of x? It gives you 1. So you have I here, so I dot I. So you get 1. Similarly with the second and third term also, you'll get j dot j, that is 1, plus k dot k is equal to 1, which is equal to 3. So we have divergence of vector r bar. If r bar is in this form, it is equal to 3. We need this result to solve the given problem. So here by taking phi is equal to r to the power n and vector a bar is equal to r to the power n, now apply this vector identity here. So what is this vector identity? You have here, it is equal to phi. What is phi? R to the power n, using this, into divergence of r bar, divergence of vector r bar, plus r bar dot gradient of r to the power n. Okay, r bar gradient of r to the power n. So you have here, by using that vector identity 3, okay, so we have here, this is equal, this implies that divergence of r to the power n into r bar is equal to r to the power n. And what is divergence of r bar? As we have shown here, it is equal to 3. So you put 3 here and then plus r dot, what is the gradient of r to the power n? Gradient of r to the power n, we have discussed it from the beginning, it is nothing but nr. This is equal to nr to the power n minus 1 into gradient of r. But gradient of r here is nothing but 1 upon r. This one I have solved in the class also, 1 by r into vector r bar. So I'm going to use this result here. So I'm going to apply here. So you have r dot, instead of gradient of r to the power n, replace it by this, that is nr to the power n minus 1 into 1 by r into r bar. So this is equal to 3r to the power n plus r bar into n r to the power. If you bring this to the numerator, you'll get n r to the power n minus 2 into vector r bar. So this is dot. So this is a scalar quantity. So you can take it outside, 3 into r to the power n plus n r to the power n minus 2 into r bar dot r bar. So but we know that the scalar product of same vectors will be equal to 1 only, will give you r dot r will give you r square only. So we have here this is equal to, because by this a bar dot a bar is equal to magnitude of a into magnitude of a into cos of 0. Cos of 0 is 1, magnitude of a is a into a, which is equal to a square, using the definition of scalar product. So r dot r is equal to r square. So you have 3r to the power n plus nr to the power n minus 2 into r square. So this will give you 3r to the power n plus nr to the power n minus 2 plus 2 gives you nr to the power n. So which is same as r to the power n into 3 plus n. So divergence of this one, r to the power n into r bar is equal to n plus 3 into r to the power n. I'm solving this using one of the vector identity, but that is vector identity 3. By applying that result, I've got the result that divergence of r to the power n into r bar is equal to 3 plus n into r to the power n. Now let us see one more problem by using one of the other vector identities here. Prove that the vector fr into r bar is an irrotational. Irrotational means, I have discussed with you, it is when curl of that vector is equal to 0 bar. That is del cross of any vector is equal to 0. So here this is a scalar quantity. There is no dot here. Okay, it is a bracket only. Fr into r bar. This is a vector quantity and this is a scalar quantity. So what we need to show is that this vector will be irrotational if curl of this vector is equal to 0, that is del cross of fr into r bar is equal to 0. Now to solve this, you can use straight away using that determinant rule, or you can use one of the vector identity 4. What is vector identity 4? It states that curl of phi of a bar is equal to gradient of phi cross a bar plus phi into curl of a bar. So here we have, by taking phi equal to fr, which is a scalar quantity, and r bar you take it as a bar. So we have phi is equal to fr, compare this with this, and a bar with r bar. So from here now, by applying this, what is curl of f of r into r bar? This will be equal to gradient of fr, okay, into a cross of vector r bar, okay, plus phi here, that is fr, it is fr into curl of r bar. So which is equal to gradient of fr is nothing but f prime of r into gradient of r bar. Okay, I have shown you this problem in the class itself, and cross r bar plus f of r, but curl of r bar is equal to 0 vector. Curl of r bar is equal to 0 vector. So therefore this is equal to f prime of r, and gradient of r bar, as you know, that it is 1 upon r into vector r bar cross r bar. So therefore this 1 upon r into f prime r is a scale, they are scalar quantity. So you just apply the cross product on these two vectors, that is r bar cross r bar. Here you have 0 vector, okay, because curl here you mentioned that since curl of r bar is equal to 0 vector, so therefore this whole thing. But now in case of cross product of the same vectors, r bar cross r bar, this is again equal to 0, 1 by r into f prime of r into 0 vectors. Since r bar cross r bar, according to definition, it is equal to magnitude of r into magnitude of r into sine of 90 degree or sine of 0 degree, because they are the same vectors, sine of 0 degree into n cap, but sine of 0 is called 0, so this whole thing will become a 0 vector, okay, using the cross product of two same vectors. So therefore this is equal to 0. So you have curl of f of r into r bar is equal to 0 vector. And how we prove it? We are using this vector identity 4, that is curl of phi of a bar is equal to gradient by comparing it, taking phi to be f of r and r bar as a bar, and remember the result that curl of a r bar is equal to 0 vector. I have discussed this also. And what is gradient of r? You have to remember those formula. So it is 1 upon r into r bar. But always remember that the cross product of same vectors is always equal to 0 vectors by using the definition of the cross product of two vectors. So which is equal to 0. So thus we have curl of fr into r vector. So once curl of any vector is equal to 0 vector, it implies that fr into r bar is irrotational. Okay, I hope it is clear to you.